So this is going to be our unit 1.4. Technically, this is not really a notes page, but it is something that everyone struggles with, setting up word problems and how to really dissect these um, their phrasing and putting it into an equation. All right, so let's start with number one, and it tells me that the product, let me move this thing. It tells me that the product of a number of seven and a number increased by three is equal to twice the number subtracted from 39. Find the number. So in this example, I'm not going to actually solve it for you, but I'm going to show you just how to set the equation up, and then it's your job to solve. Okay, so we can look at a few things. I'm going to highlight some key words. We see the word product. Okay. We see increased by. We see one that says is equal. Oh, this is a good one. Twice. You need to know what twice means. And then subtracted from. So we have a few different things going on here, okay? So the first one is the product of seven and a number. Well, we know that product means multiplication. So if we have a product of seven and a number, then we are multiplying seven and that number. So the product of seven and the number is increased by three, meaning we are making something larger. And there's two ways to make something larger, right? Multiplication or addition. In this case, since it doesn't say twice or thrice, or it just says increase by three, then we know that we are just adding. Okay. So we see that seven times the number plus three is equal, and that's a key word, right? Equal mean is equal is just going to be the equal sign, twice the number. Okay, so twice the number is going to be two times that same number. And since we use the variable n, we need to use the same variable for the next portion. So we have, I'm going to write that right here, and I'll explain why in a second. So two times the number subtracted from 39. This is where I see so many of my students get confused. So it's saying that 2n is being subtracted from 39, not 39 being subtracted from 2n. Many people will go ahead and put 2n minus 39, but that's not what they're saying. They're saying subtracted from 39, so 39 has to be first, and then we're subtracting the 2n from 39. Okay, so I just want to point that out, that we need to be careful in the direction that or the order we're putting these numbers in. So that means 2n, oh, sorry, that means 39 minus 2n. So this is the equation that needs to be set up for number one. Okay. Let's look at number two. So this one gets a little bit more interesting. Okay. It says 5 less than twice a number is equal to 1/2 the difference of 3 times the number and 13. All right, so the first portion isn't too hard to spot out. It says 5 less. So we know, oh, where's my pen? So we know we're subtracting. So 5 less than twice a number. Okay, so let's say I have $10, right? And you take away 5, now I have 5 less dollars. Well, if we have 5 less of something, we know that 5 has to, -5, or subtracting 5 has to come after the first step, which is twice the number. So 2 times 5 less than twice the number is equal. So we have another equal symbol, right? We have that we need to be using, is equal to 1/2 the difference of 3 times the number and 13. Okay, so what is 1/2 of something? Well, if I have $10 and I want to find out 1/2 of $10, I would multiply 10 times 1/2, which would be 5. In other words, I'm taking my 10 and I'm dividing it by 2 to get 5, right? So if we are looking at this problem And they say one half, the difference of one half of this right here, I'm going to put this in the parentheses, the difference of 3 times the number, then I'm going to take whatever that expression is and divide it by 2. Okay? So the difference of 3 times the number and 13. So if I have 3 times my number and the difference of 13, right, I can write it in the order they gave it to me. So I'd have 3 times n minus 13, all of that divided by 2. Okay? That's one way you can write it, and I'll take it another way as well. So we would keep the first portion the same. That would be 2n minus 5 equals 1 half. So you could do 1 half times 3 times our number minus 13. Okay, so either of these will work, whichever way makes more sense to you. But just remember that when you have half of something, you're just dividing it by 2. So you can multiply by 1 half or you can divide by 2. They're both the same thing. Okay, so it says the length of a rectangle is 1 more than 4 times its width. If the perimeter of the rectangle is 62 meters, find the dimensions of the rectangle. Okay, so we could look at this visually. We could do this a few different ways, and I'm going to show you visually what we're doing, and then I'm going to show you the algebraic way to set up that equation. So we have a rectangle, and they tell us that the perimeter equals 62. Well, we know that the perimeter is the distance around our rectangle, okay? And it says the length, the long side of the rectangle, is 1 more than 4 times its width. Well, if I have 4 times my width plus 1 more, that's going to be my length. And my width, they didn't tell me. That is actually our independent variable, meaning the width is what we're going to be using to build everything else on top of, okay? Once we can find our width, we can plug it in to find our length. So we need to focus on finding what W is. All right, well, we know that a rectangle, we have 2 congruent sides and 2 other congruent sides, right? So the width of this side is going to be the same width of this side because it's a rectangle. And this side would also be the same length, which is 4W plus 1. Well, if my perimeter is 62, then I can say 62 equals my width plus my length, which is 4W plus 1, plus another width, the other side, plus the last side. Okay, so what we could do at this point, right, is combine all of our like terms and then solve for W. But I want to show you a better way to set this up using our perimeter formula. Well, we know that the formula for perimeter equals 2 times our length plus 2 times our width. And we know that we can plug 62 into our perimeter, into our P, because that's our perimeter. And we do 2 times our width, which is 4W plus 1, plus 2 times our width. I'm sorry, 2 times our length plus 2 times our width. And at this point, we could just distribute and solve for W. So that's what I'm going to do. 2 times 4 is 8W. 2 times 1 is 2, plus our 2W. We combine our like terms. And then we can bring our 2 to the other side, which gives me 60 equals 10W. So that means that 1W, or W, equals 6. Now that I have my width, all I have to do is plug it back into the expression that I have for my length to find what length is. So length equals 4 times W plus 1. And so we could put 4 times 6 plus 1, which is 25. So my length has to be 25. And of course, we can check that. We know that if this is the length, right, then we have 2 lengths. So we would have 25 plus 25 plus 6 plus 6, which would be 50, plus 12, which does in fact equal 62. Right. Let's look at another one that you may not be familiar with, depending on if you were in my Algebra 1 class or not. So we're going to talk about the logic of this problem. The sum of three consecutive odd integers is 93. So they're telling me, oh, and they want us to find the integers. So the sum, or S, is going to equal three consecutive integers. So let's just name those three consecutive integers X, Y, and Z. So our X plus our Y plus our Z has to equal the sum, which is going to be 93. So let me plug in my 93. And I'm going to make a little bit more room to have space to work. Okay. So if we can, let's think about the logic, right, of our integers, the fact that there are three consecutive odd integers. Well, what is a consecutive odd integer? If I have a number line, or if I have a list of numbers starting from 1, consecutive only means that they're right next to each other. So 1 and 2 are in a row, they're in order, and they are consecutive. Well, but if I want consecutive odd numbers, I would have to skip my even numbers. So 1 and 3 would be consecutive odd integers. 3 and 5 would be consecutive odd integers. So let's just say X was 1. Let's say that X was 1. And well, and obviously not for this problem, but if X was 1, what would my Y be if it was a consecutive odd integer? It would be 3. Right? So to get from X to Y, I would add 2, right? 1 plus 2 is 3, okay? Well, what if I want to get to Z, right? My next consecutive odd integer would be 5, so Z would be 5. And to get from 1 to 5, I would have to add 4, okay? So now I have a rule where if X was 1, and I need to find my Y, I could say that Y equals X plus 2. If I wanted to find my Z, I could say that Z equals X plus 4, right? To get from X to Z, I would have to add 4. Well, now I have a rule that applies to every consecutive odd and even integer, that my X would equal itself. I don't know what X is in this case. Okay, if it was 1, right, then I would just plug 1 into my X here to find my Y. If 1 was my X, then I would plug it in here to find my Z. But since I don't know what my X is, I can use these right here and plug them into my equation to find X. So let me show you what that looks like. If I have 93 equals X, well, I know that Y, remember Y down here? My rule for my Y is going to be X plus 2. So if Y equals X plus 2, I can plug X plus 2 where my Y should be. Same thing for Z. If Z equals X plus 4, then I can plug in X plus 4 where Z should be. Now I have a problem that I can't solve because I only have one variable instead of 3. All right, so let's simplify our terms. So X, since everything is addition, I can just get rid of these parentheses. And I combine my like terms. I'm going to move these down because I will need them. So X plus X plus X is 3X. And then 2 plus 4 is 6. So now I have 93 equals 3X plus 6 going to subtract 6 from both sides. I'm running out of room here. That would be 87 equals 3x. If I divide both sides by 3, I would get x is 29. Okay, so I found that my x equals 29. So I'm actually going to plug that in over here, and I'm going to give myself more room to work. Okay, since I established that my x is 29, then can't I find my y since I know that what my x is for this equation, right? So my y would equal 29 plus 2, which would be 31. So I just found out that y equals 31. Same thing here. If I plug my x into this equation for z, z would equal 29 plus 4, which is going to be 33. So I have 3 numbers that I think are my odd consecutive numbers, and I can check that all 3 of them are indeed odd. 29 is odd, 31 is odd, and 33 is odd. Now I can add them. 29 plus 31 plus 33 is in fact 93. All right, let's take a look at number 12, since you may be unfamiliar with this process, and this will be the last one we'll be going over. Find 3 consecutive even integers such that the sum of the smallest integer and twice the median integer is 20 more than the largest integer. Okay, so let's go back to this rule, right? When we have 3 consecutive even or odd integers. Well, going back to what we said earlier, if I have 1, 2, 3, 4, and 5, you know what, let me add one more. Let's add 6. Since we're dealing with even numbers, we could double check that the rule is the same. Since 2 is my first even number, this can be my x. To get to my second even number, I would be adding 2, right? So if 2 is my x, then my y would have to be 4. And if my 2 is my x, I'd add 4 to get to the next even integer, and 6 would be z, right? That would be my last consecutive even integer. So the rule is the same, where x is going to equal x, y is going to be x plus 2, and z is going to be x plus 4. Okay, so we have our rules set up for this problem. And now let's take a look at how we're going to set the problem up, because it is a little bit more work than the last one. So it says find the 3 consecutive even integers such that the sum, that's a good word to highlight, the sum of the smallest integer and twice the median integer is 20 more than the largest integer. Well, let's highlight the word more as well. Okay, so they're telling us that the sum of the smallest, and we know that x has to be our smallest, so let's put x is our smallest plus twice the median, and median just means middle, right? The number in the middle. So it would be 2 times the middle, which is our y, is, right? They tell us is 20 more. And since it's addition, it doesn't matter which one comes first. It only matters for subtraction. So I'm going to put my 20 first. 20 plus the largest integer. And my largest integer is z in this case. So now I have an equation that's a little bit different than the last one, right? But the rules are still the same in that I can plug in or substitute these into my equation to solve for x. So let's do that. So I'm going to rewrite it as x plus 2 times y, which is going to be x plus 2, right? My y is x plus 2, equals 20 plus z, and our z was x plus 4. Okay, So let's go ahead and get rid of our parentheses by distributing. And in this case, we know that there's a 1 right here. And since it's just a 1 and a positive 1 at that, this is all going to stay the same. So I'm going to bring this down. This is going to be x plus 4 plus 20 equals x plus 2x plus 4. Let's bring all of our x's to one side. So I'm going to bring this x over here, and that actually cancels that one out. And let's bring our 4 to this side, and that actually cancels that one out. So now I have 2x equals 20. So that means that 1x has to equal 10. Okay, and that's a good sign because it has to be a consecutive even number, and 10 is in fact even. So now that I found that x is 10, oops, 10, then I can plug each of these into my y and my z to find that. So if I have 10 plus 2, then I know that my y has to equal 12. And then 10 plus 4, so my y has to equal 14. So now I have 2, 4, 12, and 14. And we can plug these numbers in to make sure that they are that they work. So I think that this is 10 plus 2 times my y, which I think is 12, equals 20 plus my z, which I think is 14. Take care of this multiplication. I have 24 equals 20 times 14. Let me 20 times 14, let's handle that first. This is 34. And let's bring down our 10, of course. And 10 plus 24 is 34. And 34 does equal 34. So we know that we have the correct variables.